morning, students. This is Dr. GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, I would like to discuss about fluctuating stresses. In previous sessions, already we have studied fatigue failure and endurance limit. Now, in this session, we will see what are the fluctuating stresses and how to calculate fluctuating stresses by using different methods. Fluctuating stresses, actually the failure points from fatigue test made with different steels and the combinations of mean and variable stresses. So already we have studied about this alternating stresses, and these alternating stresses are we can calculate by using stress time diagram. So those stresses are plotted in a figure as a function of stress amplitude and mean stress. So stress amplitude we can calculate by using this relation sigma max minus sigma minimum divided by 2. So similarly, the mean stress take average of these two stresses sigma max plus sigma minimum by 2. So we will get mean stress and stress amplitude. So the significant observation is that in general the failure point is little related to the mean stress, and that is it is compressive, but is very much a function of the mean stress when it is tensile. So suppose the tensile stress, the failure point is some related to this tensile stress when it is tensile. So the function of this mean stress is very close, and this mean stress is when it is compressive, it is very far between these failure points. So how to draw these failure points and how to calculate the fluctuation stresses, we will see. I will show you one figure. So generally, see here the alternating stresses are drawn on y-axis and the mean stress drawn on the x-axis. Okay, you can represent with the sigma m and alternating stresses sigma a. So here for calculating fluctuating stresses, there are three methods. One is Goodman line method, another one is Soderberg line method, and third one is Gerber parabola. So how to calculate the fluctuating stresses by using these methods, I will explain. So one by one we will see. First, draw a line, straight line between yield point stress and the endurance limit. So endurance limit, what is endurance limit? Already we have discussed in previous sessions. So endurance limit is the maximum amplitude value of the repeated stresses. So that is we can say the endurance limit or the fatigue strength of the particular component or material. You can represent with sigma E or SE. So similarly, the SY is the yield stress. Yeah. The endurance limit for a ductile material depends upon the yield stress. The endurance limit or fatigue strength of a brittle material depends upon ultimate strength. So here the line drawn between this yield stress and endurance limit. So this is the maximum limit of the material sigma E, and here showing this the yield stress of the particular ductile material. This representation line is called as the Soderberg line. So by using this method, we can calculate the fluctuating stresses. So what are the fluctuating stresses? Mean stress and variable stresses. And one relation is there, I will show you. And the second one is Goodman line. So Goodman line is used for the brittle materials. Here a line, a straight line drawn between the ultimate stress and maximum limit. That is the endurance limit value. It shows Goodman line. So always the Soderberg line is used for ductile materials and Goodman line is used for brittle materials. And third one is Gerber curve. Gerber curve is drawn between endurance limit and ultimate stress value. Whether ductile or brittle materials, it will be useful. So this is yield line. So beyond this yield line, the failure points are shown here. These all are failure points. So behind this line, the component will fail. See here shown the failure points. So first one is the Goodman method for combination of stresses. So see here is straight line connecting the endurance limit and the ultimate stress. So ultimate stress and endurance limit as shown by line A and B. So similarly, it's next one endurance limit and this the mean stress value. So that is the maximum value is shown and it is shown in the figure as a CD line. Clear? So and then PQ, the P and RP and here shown the mean stress and these are variable stress. These two are fluctuating stresses. So we have to here we have to calculate the mean stress and the variable stress by using this diagram. So take a similar triangles from the as shown in the figure, the COD and PQD. So write down the equation and then finally you will get 1 by factor of safety is equal to sigma mean by sigma u plus sigma v by sigma e. So here sigma m is mean stress and ultimate stress and this variable stress and sigma e is the endurance limit value. By using this formula, we can calculate these variable stresses of a brittle material. The second one is Soderberg method. So it is a Soderberg method also, it is a straight line, but connecting the endurance limit and the yield strength value. So already shown in diagram in previous slide. So as shown by the line AB in a previous figure. So this line is used when the design is based on yield strength only. Clear? So I will show you diagram. The AB connecting sigma E and sigma Y. Sigma Y drawn on a plot on x-axis and sigma E is on y-axis. Clear? This AB line, Soderberg line, already we have discussed about this method, and then this one is a safe stress line drawn between the variable stress maximum limit, the maximum value, that is a safe value of the particular material and the D. So these are the variable stresses. By using this diagram, we can calculate the variable stresses using factor of safety. So write down this 1 by factor of safety is equal to sigma m by sigma y plus sigma v by sigma e. So here the mean stress sigma m is mean stress and sigma y is the yield stress value, and sigma v is the variable stress and sigma e is endurance limit value. So see it this method is depends upon the yield strength of the material. So it means always this method is suitable for ductile materials only. Clear? In previous Goodman line method used it for brittle materials. Clear? So by using these two formulas, we can calculate the fluctuating stresses. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.